So welcome back everyone. Today we will enter to the second part of this PLDs and memory. This part we will see the basic concepts of ROM, read-only memory. So what is the organization of the ROM? Before we start discussing about the block diagram of the ROM, what is ROM? This is a read-only memory, right? And it is essentially a memory device in which permanent binary information is stored. That is what we know. That means it can be programmed, and when it can be programmed, it is called PROM. Okay, the process of entering information in a ROM is known as programming. ROMs are used to store information which is of fixed type, such as tables for various functions, fixed data, and instructions. Now, here we can see the block diagram of a ROM. It consists of k inputs and n outputs. The input, these inputs, they provide the address for the memory, and the outputs, they give the data bits of the stored word which is selected by the address. The number of words in a ROM is determined from the fact that k address input lines, they are needed to specify 2 to the power k words. And note that ROM doesn't have data inputs because it doesn't need to write, right? It doesn't have a write operation. So integrated circuit ROM chips have one or more enable inputs, and sometimes they come with three-stage output to facilitate the construction of a large arrays of ROM. Now, if you consider over here 32 by 8 ROM, the unit consists of 32 words. The unit consists of 32 words of 8 bits each, and there are 5 input lines. You can see over here there are 5 input lines that form the binary numbers from 0 to 31 for the address. Okay, and the internal logic construction of the ROM we can see over here. These 5 inputs are decoded into 32 distinct output by means of this 5 by 32 decoder. ROM is basically what? It is a decoder, right? With k inputs and 2 to the power k output lines, right? 2 to the power k output lines. And so what can we observe over here? ROM is having, what did I say? It is having k inputs and 2 to the power k output lines, followed by a bank of OR gates. And each output of the decoder represents the memory address. Okay, so it represents what? It represents the minterm of the input variable. So the 32 output of the decoder are connected to each of the 8 OR gates, right? Now, the array logic conversion is used in complex circuits. Each OR gate must be considered as having 32 inputs. Each output of the decoder is connected to one of the input of each OR gate. Okay, since the OR gates, they are having 32 input connections, and there are total how many OR gates? You can see 8 OR gates, right? So this ROM contains 32 into 8, that means 256 internal connections. Okay, in general a 2 to the power k by n ROM, a 2 to the power k, a 2 to the power k by n ROM. Okay, it will have an internal k by 2 to the power n k by 2 to the power n decoder and n OR gates. Okay, each OR gate has 2 to the power k. Each OR gate is having 2 to the power k inputs which are connected to each output of the decoder. Okay, now these 256, all these 256 interconnections are programmable. A programmable connection between these two lines, the programmable connections between the two lines is logically equivalent to a switch, right? And that can be altered to either be close or open. Close meaning that the two lines are connected, and open meaning that the two lines are disconnected. Okay, and the programmable intersection between the two lines is sometimes called the cross point. All right, now there are different types of ROMs. Two types of semiconductor technologies are used for the manufacturing of ROM ICs. These are bipolar technology and MOS technology, which use bipolar devices and MOS devices respectively. The process of entering information into a ROM is called the programming the ROM. Okay, bipolar ROMs and MOS ROMs use different mechanisms of programming. Depending upon the programming process employed, ROMs are classified as mask programmable read-only memory, which is also called MROM. So in this type of read-only memory, the user specifies the data to be stored to the manufacturer of the memory, and the data patterns specified by the user are programmed as a part of the fabrication process. Once the programming is done, the data pattern can never be changed. This type of read-only memory is referred to as ROM, MROM. These ROMs are highly suited for high volume usage due to their low cost. Next is programmable read-only memory or PROM. This type of memory comes from the manufacturer without any data stored in it, that is empty. The data pattern is programmed electrically by the user using a special circuit which is known as PROM programmer. It can be programmed only once during its lifetime. Once programmed, the data cannot be altered. This type of memory is known as PROM, and these are highly suited for high volume usage due to their low cost of production. Next, we have erasable programmable read-only memory or EPROM. In this type of memory, data can be written any number of times, that is, they are reprogrammable. Before it is reprogrammed, the contents already stored in the they are erased by exposing the chip to ultraviolet radiation for about 30 minutes. This type of memory is referred to as the EPROM. EPROMs are possible only in MOS technology, and programming is done using a PROM programmer. Next, we have electrically erasable and programmable read-only memory, EEPROM or E2PROM. This is another type of reprogrammable memory in which erasing is done electrically rather than exposing the chip to UV radiation. It is referred to as the E2PROM or electrically alterable ROM, EAROM.